Okay, so this is the same question, only now we've got light with, it's got a little more energy, right? It's got a shorter wavelength, right? And now it says the same plate. All that means is that we're going to use the same work function, right? So what was that work function? 3.10 electron volts, right? So we know our work function. 3.10 electron volts, right? Okay. So the first step here is let's figure out the energy that this thing has. And we got to do it in electron volts, right? So E is hc over lambda, right? So that's going to be 6.63, 10 to the minus 34th, and that's joule seconds. All right, times 3.00 times 10 to the 8th meters per second, right? Divided by 180 nanometers, right? 10 to the minus 9th meters, right? Nano. All right, so what is that? Okay. And then I gotta go here. I'm so lazy that I'm actually just using the thing I just typed in. Okay, so 180 times 10 to the minus 9th. Okay, and this is going to give us an answer, of course, in joules. Right? If you look at the units here, seconds and seconds cancels, meters and meters cancel, we'll end up in joules. Joules. All right, 1.105 times 10 to the minus 18th joules. And then we're going to divide that by 1.60 times 10 to the minus 19th. And that is, what is that? That is joules per electron volt, right? And if we do that, if we divide that, if we do that calculation, we'll get 1 over electron volts. So that'll be electron volts. Okay, so divided by 1.60 times 10 to the minus 19th, you get 6.90. So the photon energy is equal to 6.90625. That would be electron volts. Okay, and then now we get into basic photoelectric effect calculations, right? And so in the best case scenario, right, where when we're talking about the stopping potential, right, the photon energy, if we talk about energy, right, the photon energy turns into work to remove the electron from the metal plus the kinetic energy that the electron gets, okay? Now, in most cases, also a little bit of heat is generated, and so they don't quite get that much energy. So what we're saying is plus 0 amount of heat, right? Oh, heat. We're getting 0 heat, right? I don't know, that didn't make it better. All right, so we're just saying that this is the most efficient process. In the best case scenario, all of that energy either goes to work or kinetic energy, okay? So let's go 6.90625 turns into, the work we know is 3.10 because it's the same plate, right? So it's the same work function as the previous problem. Okay, plus the kinetic energy. And this is why they always say Ke max, right? And this is related to the stopping potential, right? Okay. All right, so, you know, this is just a long roundabout way of saying I'm going to subtract 3.1 from the answer I just got. But this is why. Okay, so 3.806, okay. So the kinetic energy, the maximum kinetic energy that it could have is 3.80625, or 3.81, that's a 3 electron volts. Okay, but in reality, most of them are going to have less than that because some of the energy was wasted as heat. Okay? All right.